This is Unit 3, Section 4. We're doing textbook Section 3.5. We're looking at systems of nonlinear equations. So before we get into that, first let's just talk about equations. So all equations in two variables have an infinite number of solutions because for each unique x value, there's a solution of a y value, right? So that's why it's a line and there's usually arrows on both ends to show that it goes forever. And every single point on that line is considered a solution of that equation. When you introduce two equations, or a system of equations, where they intersect is considered the solution for the system. So while each line on its own has an infinite number of solutions, there's usually only going to be one point, if it's linear equations, where they're going to intersect. It's possible for them to not intersect at all, which means there is no solution for the system, but where they do intersect would be considered the solution. So in this case, it would have been -4, -2. We're going to look at nonlinear systems. So that would mean where one or both equations are nonlinear. So in the example here, we have a nonlinear first equation. It's quadratic, right, because it's x squared. And the second equation is linear because it has x to the first power. When we're dealing with systems of nonlinear equations, just as before, we could have a solution. We could have no solution. The only difference is we're not going to have infinitely many solutions, but it is possible to have two solutions if we're looking at a quadratic and another quadratic, or a quadratic and a linear. Right? No solution is still possible if they never intersect, and one solution is possible if they just touch at a single point. So we're going to start with our solve the system by graphing. So I'm actually going to minimize this a bit. Let's get it over here. All right. So we have y equals x squared minus 2x minus 1. And y equals -2x minus 1. So if I were to go ahead and graph both of these, I see that they intersect. So let's get this out of the way. We have a point right here of intersection, 0, -1. So that would be our solution. That's all we have to put, right? If we're solving the system by graphing, we're looking for the point or points where they intersect. So let's look at another one. Let me get rid of both of these. And now we have y equals x squared plus 6x plus 4, and y equals -x squared plus 2x plus 4. So if I go ahead and graph both of these, now I see that they actually intersect twice. Click on one so we could see the points. We have one here and one here. 0, 4, and -2, -4. All right, so this system happened to have two solutions. So looking at our next example, hold the phone. Okay, there it is. Looking for our next example. Nope, that's not right. This is the try problem. Hold on. All right, sorry about that. All mixed up. All right, so this is our example. So we have 2x squared plus 10x plus 8. And we have -x squared plus 2x minus 7. So I'm going to go ahead and graph both of those. And if I look at this, they don't cross at all, right? This is going to go up forever, this is going to go down forever, and they never get to meet. So that means this is actually no solution. Okay, and that would be our answer for that one. So I'm going to have you try this one. You could pause it, and I will show the answer. All right, so these graphs actually intersected at 2 points, 5, 4, and 1, 0. Graphing is not the only way we're going to solve our systems. We can also solve them in the ways that we solved linear systems. So that's substitution and elimination. If you recall, substitution is where we get one of the variables by itself and then we plug it into the other equation. So for this one, I have an x squared and an x already in this problem, so it's best to get rid of the y. So if I'm going to get rid of the y, that means in this equation, I want to solve for y. So if I want to solve for y, let's get rid of the x on both sides. So now I have y equals negative x. Oh, that's bad. Let's try that again. Plus 4. So in this equation, in place of the y, I'm going to put negative x plus 4. So we have x squared plus x minus what I'm going to plug in for y equals negative 1. And let's plug in that negative x plus 4, right? That's what y was equal to. I'm plugging it in place of y. So now I'm going to distribute the negative. So we have x squared plus x minus a negative x is plus x minus a positive 4 is minus 4. So if I combine my like terms, and then I can add 1 because I always want a quadratic equal to 0 if I have an x squared and an x term. I could also solve this by completing the square if I wanted to, but this one's probably quickest to solve by factoring. Because if I look at this, I'm looking for what multiplies to negative 3 and adds to positive 2. That's a positive 3 and a negative 1. So my solutions are x equals negative 3 and x equals 1. So that's not my final answer though, because I'm looking for where the lines intersected, which means each one has an x and y value. So I'm going to take these two x values one at a time and put them back into either of my original equations. All right, I could put it into the one that was untouched or the one that I moved. I'm going to stick it in this one just because it saves me some time for solving. So we're going to have y equals negative x plus 4. So that's 3 plus 4, or 7. So that's a solution of negative 3, comma 7. And then I'm going to plug in 1 as well. So y equals negative 1 plus 4, which is a 3. So that's 1, comma 3. So those are my two solutions for this particular system. So you go ahead and try this one. You could pause it, and I'm going to show the answer. All right, so let's check our answer here. We should have gotten negative 6, comma 19 and 2, comma 3. So that's substitution, and then we also have elimination, and elimination is sometimes called linear combinations. Either way, we're getting rid of one variable by combining the two equations. So I'm looking for one of the variables to be the positive and negative of the same number. When I look at the equation, I have a y squared, an x, a y, and a number. So the one that's kind of the odd man out is the x value. So that's what I'm going to end up canceling out with these two equations. So in order for this to cancel out with this, in order to get the x gone with the 9x, I need to take this entire equation here and multiply it by negative 9. Right? That'll give me negative 9x, which will cancel. So the top equation doesn't have to change at all. But the bottom equation, when I multiply everything by negative 9, I'm going to try to line stuff up. So that's negative 9x minus 9y minus 36 equals 9 times 0 is 0. So nothing to cancel out with that. So we're going to say negative 3y squared. Those are gone. Negative 3y and negative 9y is going to give me negative 12y. And 24 negative 36 is going to give me negative 12. So now I have a quadratic that I can technically divide a GCF out of. So I'm left with y squared plus 4y plus 4 equals 0. So we're looking for two numbers that multiply to 4 and add to 4. So that's 2 and 2. So since it's the same number, I don't have to solve it twice, right? The answer is just going to be y equals negative 2. And now I could plug that back in to find out what x is. So I'm going to put it into this equation here. So x plus negative 2 plus 4 equals 0, or x plus 2 equals 0, and x is negative 2. So that means my overall solution, x comma y, is negative 2 comma negative 2. Let's try another one together. We're going to solve the system also by elimination. This time I have a y squared and an x. There is no really odd man out, but it's always harder to cancel out a squared, so let's cancel out the x. So in this case, I'm going to have to multiply both equations because nothing's going to nicely cancel. So if I want them to turn into, let's say, 6x and negative 6x, the top equation is going to get multiplied by 3, and the bottom equation is going to get multiplied by 2. The only thing I'm going to do here is I'm going to write plus 0y, just because I do have a y in the other equation, and I want to be able to line things up as I'm writing them. So if I multiply everything in this equation by 3, that's negative 3y squared plus 6x plus still 0y, 3 times 0 is 0, minus 153 equals 3 times 0 is 0. And now in the second equation, I'm going to multiply everything by 2. So that's negative 6x plus 2y plus 8 equals 0. So the negative 3y squared will be brought down. The x's cancel. We get plus 2y. And then negative 153 plus 8 is minus 145. So if I try to factor this, nothing comes out of everything, right? Because that's a 3 and that's a 2. Already I know nothing comes out. So my best bet's to just try quadratic formula. So I know my first step is b squared minus 4ac. So that's going to be 4 minus. Now, negative, negative, negative is a minus, right? That's why I put minus there. 4 times 3 times 145 is actually 1,740. So if I do 4 minus 1,740, I have negative 1,736. If I try to put that under a square root, I'm going to get no real solution. So that's actually the answer to this. No real solutions, right? Or no solution. Either way, I'll take it. All right, so if when you go to solve, you end up with a quadratic formula problem and you get a negative discriminant, there's no real solution for that system. You go ahead and try these two. I'm going to pause and show the answer. All right, so for number 3, I chose to eliminate the y's. I multiplied the second equation by 4. Doing that, I ended up with a quadratic of negative x squared plus x minus 19 equals 0. So doing the discriminant, I get 1 squared minus 4 times negative 1 times negative 19, and I get a discriminant of negative 75. So that is no real solution. For number 4, I decided to get rid of the y's as well, so I multiplied the second equation by negative 1. Doing so, I got 8x squared plus 64x plus 128. I can divide everything here by 8, so I'm left with x squared plus 8x plus 16. The two things that multiply to 16 and add to 8 are 4 and 4. So my solution for that part is x is negative 4. And then I put it back into this equation. So we have negative 4 plus 2y plus 2 equals 0. I get y is 1. So my final answer is negative 4, 1. The last one we're going to do is actually a little bit of geometry, because this is the equation of a circle. When there's an x squared and a y squared in the problem, that actually forms a circle. So we're looking for the intersection of a circle and the line. So they're telling us to solve by substitution, which is great because we already have y set up by itself. So what we're going to do is we're going to replace the y in this equation with everything it's equal to. So that means when I do x squared plus y squared, I'm going to put a big set of parentheses where the y goes. And now I'm going to substitute in x plus 2. So what this means is I have all of x plus 2 squared, or I can write it out as x plus 2 times x plus 2. And I'm going to recommend you do that because we cannot distribute the 2. That's not the way it works. What we're going to do is I'm going to take the x and distribute it twice and the 2 and distribute it twice. So that's x times x is x squared. X times 2 is 2x. 2 times x is 2x plus 2 times 2 is 4. So I have a lot of like terms to combine. So that's 2x squared plus 4x plus 4 equals 20. Right, this is a quadratic. Let's move that 20 over. So when I subtract 20, now I have negative 16 there. There's a GCF here, right? They're all even, so we can divide out 2. So we're left with x squared plus 2x minus 8 equals 0. And now this is factorable. So we want to know what multiplies to negative 8 and adds 2. That's a 4 and a negative 2. So that means x equals negative 4 and x equals positive 2. So I'm going to go ahead and plug them in here. Let's get some different colors. So y equals, let's plug in negative 4. So we get negative 2. So negative 4 comma negative 2 is a solution. And now let's plug in positive 2. So y equals 2 plus 2 or 4. So that's 2 comma 4. And those are our solutions for that system. And that is the end of our lesson.